Okay, so let me start by saying the most important thing you can do, or I can teach you, is how to graph a rational polynomial. A rational polynomial, two polynomials on top of each other. And it's really annoying, and it's something you will have to learn. So you might as well learn it. The sooner you learn it, the better. Right away, you can glean some information. For instance, the first bit of information you should glean is what happens when x is 0? What is the y-intercept? Well, we plug it in here. This becomes 0, and this becomes 0. And we get minus 24 over minus 32, which is 3 over 4, I believe. Okay, which means that when x is 0, the y-intercept is 0.75. So right away we get 0, comma 0.75. And it's very easy to get mistaken and say, what? It's just minus 24 because my knowledge of polynomials, but you got to remember could be some numbers down here. You also want to make sure it fits, that it's not an exclusion down here that creates a asymptote. So right away we know some information. That's the first bit we know right there. 0, comma 0.75 is the y-intercept. Then you should always see if you can factor. And let me let you in on a hint. You will need a quadratic equation somewhere along here, either to find out the factors, the x-intercepts, or to find out the max-min. You will need it one way or the other, but always check to see if you can factor these. And sure enough, if your teacher's given it to you to test, chances are you need to be able to figure it out quickly. It's going to be factors. And from that, you should then run and figure out your x-intercepts. Well, your x-intercepts only matter when the numerator is equal to 0. The numerator can only be equal to 0 when one of these brackets is equal to 0, which means there's an x value in here that will create a 0 in this bracket. In this case, it's 4, and minus 2. That's the only way you can create a 0. The next step is to make sure it doesn't create a 0 at the bottom, and it doesn't. So therefore, these are your x-intercepts. That's great information, easy to get right away. Your next step should be to figure out your vertical asymptotes. Okay, so looking at the bottom, the vertical asymptotes are created when the bottom is 0, which means either of these brackets becoming 0 will create that. Which means when x is 8, you get a 0, and when x is minus 4 is equal to 0. Therefore, you should have your vertical asymptotes on your graph labeled as x is equal to minus 4, a vertical line, and x is equal to 8. Your graph will never cross those points. Often, it will try to hug those points, and it will race to try to hug them. So you're often going to see your graph try to reach those asymptotes. Your next one is your horizontal asymptote. And for this, you have to go back to your basic rules. If x is much smaller than the power of the bottom numerator x, is much smaller power, then there's pretty much no asymptote. If they're equal power, then you have to look at the numbers in front. So in this case, we got an x squared and x squared. They're equal power, and the number in front is 3 and 1. To figure out the horizontal asymptote, you now just ignore those and determine what this number is divided by this number. Well, it's 3, which means I have a horizontal asymptote at y is equal to 3. This is great information already. You should also know that now that we're in section 4.1, we're going to be taking the first derivative of this, which means we'll need the quotient rule. And we're going to probably use the second derivative. Now 4.1 is all about using the derivative on either side of a max-min to figure out if it's a max or min, because if it's sloping up on the left side of this point and sloping down on the right side, in other words, if it's negative derivative here and positive derivative here, it's always a maximum. If it's a min, it's going to have a negative derivative on the left side and a positive derivative on the right side, which tells you it's a min. However, I will tell you that whatever min x value you find, create the second derivative, which is simply the derivative of the first derivative, plug it in, and if your result from the second derivative is negative, it's a max point. If it's positive, it's a min point. So again, write it down. Second derivative, when you plug the x value you found from the max point, or min point. If it's a negative, it's max. If it's a positive, it's a min point. I'm going to use both methods because taking a derivative on each side takes a long time. Okay. Now that you've found your key points, I want you now to start using these boxes right away. So it's important to find out what happens to the graph at negative x infinity, and it's important to find out what happens to the graph at plus infinity. Now I know it's going to reach the horizontal asymptote, but it's important to know on which side it is. Okay, so that's one thing. Second, on all these little spikes here, you should put your farthest left, if I were to graph my thing, your farthest left, either your farthest left x-intercept or vertical asymptote, whichever is furthest left. So let's have a look. X is equal to 8, that's way on the right. X is equal to minus 4, quite a way on the left. X is equal to 4, that's on the right. And that's on the left, but this is way more on the left. So I'm going to put my minus 4 on one of these spikes. Okay. Then I'm going to find the next point along. Well, it's either minus 2, 4, or 8, and it's clear that minus 2 is the next point. So I'm going to take my minus 2, and I'm going to put it on one of these spikes. And so you can see it can go from asymptote to x-intercept to asymptote to x-intercept. So what's my next point? I got an 8 vertical asymptote, but I also have a 4 x-intercept. So it's clear to me that it's the 4. So I'm now going to put the 4 right there. I know that minus 2 disappeared. So right now I go asymptote, x-intercept, x-intercept. So if you want, you can even also do this. You can call it A and an x-intercept. And just do an x, whatever helps for you. An x-intercept, if you need to. And then the numbers will solve themselves. And then the last number, the x-intercept, the 8. And then after that, you want to find out what happens with the plus infinity. And if you don't need any more boxes, that's all the boxes you need. Now, what do you put here? Well, in your factored form, and if it doesn't factor, you just put this whole thing here. You would just put this whole thing here. But since this does factored, you can ignore the 3. And we're going to put them in sort of numerical order. X minus 8. Okay. X minus 4. And actually, let's start with the smallest one first. Whoops. I did it. I want to get rid of that line. Why does it have that line? That line's still there. Oh well, looks like I'm going to get rid of that line the old-fashioned way. Okay. My problem with these lessons is I'm always too messy. So I'll just put that back. Okay, and I'll do it all over again. So I had a minus 4 here. I have a minus 2. Doesn't help to do it twice. 4. I got an 8. Then I'm going to put my thing in its own separate box just out of curiosity. And then I'm going to get rid of all my chart. Since I do have the factored form, I'm going to take the most. It doesn't really matter, but I prefer going in sort of a numerical order, which is the farthest left thing first. And you put them all in here, just like that. If you want, you can put all the denominators together and all the numerators together, and that's fine as well, to help you understand what's going on. But this is essentially numbers smaller than 4. This is between these two, and right here for our sample group, this is between these two. This is between these two, and this is just to the right of it. I like taking just to the right and just to the left of an asymptote to see where the graph is going. And you should also maybe incorporate that into the last two instead. So if I was going to add 2 extra, I would add here and here, and maybe this and this. And if you want, if you have time, it would be just left and right of asymptotes. Okay? Not necessary yet. So if you're going to label it all up, great. And then your last line is this is positive, negative. And what that means is, let's take any number to the left of negative 4. Let's just take minus 5 as an example. What does this become if it's minus 5? Just in positive or negative? It becomes a negative. What does this become? Positive or negative? It becomes a negative. What does this become? A positive or negative? It becomes a negative. What does this become? A negative. So we got 4 negatives if minus 5 is in there. And if I multiply, because that means these brackets will be negative, 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 negative. And if I multiply them out, why don't I put in the 3? The 3 is a constant. And actually, you know what? you're right. Because the 3 is positive, it can have an influence. So put the 3 in there. So, and of course, the 3 is positive, right? And that's where the influence, my mistake. So when you multiply these brackets, minus times minus is a positive, times a minus is now a negative, times a minus is now a positive, and then that doesn't really change anything. And I'm putting in there more to illustrate a point that it won't really change anything. So we went positive, negative, positive, positive. So that means when I'm on the left of minus 4, I'm going to get a positive above the x-axis reading. That's great to know. Now, what about what's a number between minus 4 and minus 2? Let's take minus 3 and then do the same thing. Well, it's going to be positive in that bracket. It's going to be negative in that bracket. It's going to be negative in that bracket. And it's going to be negative in that bracket. And this, of course, is always a positive. So you get negative, then it becomes a positive, becomes a negative, then it stays a negative. So that means everything on between these two numbers will be below the x-axis. What's a number between these two? Well, we could take 0 because we already have it up here. And we already know the result's positive. So we can just say 0, it's positive because we already did it, right? And then finally, between 4 and 8, let's take 5. Okay, take 5. And over here, it's positive when I put it into there. Over here, it's positive. Even over here, it's positive. Over here, it's negative. And, of course, that's positive. So you get positive, positive, then it becomes negative, then it stays negative. So that means everywhere to the right or between these two numbers, it will be below the x-axis. Between these two numbers, it'll be positive. And you can even write this, if you want, up here. And you usually find it'll fluctuate back and forth between, but not always. And then finally, you want to look at a number that's just above 8. Let's take 9. And you're going to see that the first one's positive, the second one's positive, the third one is positive, and the last one is positive. And the plus 3 is positive. So you get all positives here, which means on this side of the graph, it's positive. Now you should also test for this number to see if it's above the horizontal x-intercept or below. And you can take a calculator and you can just take like a minus a million. So you get 3 million, right? Minus 6 million, minus 24. You can see that that 24 is, and that's 3 trillion, by the way. 3 like trillion. Just put a number. It doesn't matter. And the other one, you're going to see that it's just 1 trillion, minus 4 million, right? Minus 32. And these really don't matter. And you can see that 3 trillion minus this number is still going to be a positive number, and that 3 trillion times this number is still going to be a positive number. You just need to figure out which side of the y-intercept it's on. Well, this is subtracting 6 million, and this is subtracting 4 million, but it's only 1 trillion. So really, you should put it into a calculator. So I'm going to take negative a million. Actually, you know what? Negative 1,000 is enough, so that your calculator doesn't bog down. And I'm going to multiply times itself, times 3, minus 6 times negative 1,000 is plus, right? So you got to be careful. So I'm going to start again. Let's just take 100. Let's take a negative 100. I'm just taking a positive because when it squares, it's still positive, times 3. Then I'm going to take negative times negative 100, which is plus 600. And then I'm going to take minus 24. And I'm going to stick that in the memory. Now I'm going to go down to the bottom, and again, 100 squared is negative 100 squared is the same as a positive 100 squared, minus 4, plus 400, sorry, plus 400, minus 32. Then I'm going to take my numerator, and I'm going to divide it by my denominator, and I get 2.9497. So I can see, and it makes sense, because I was coming from a negative side, right? It's almost impossible to cross it. Then I'm just below it. So I'm just at 2.9. So I'm just below the asymptote. And you should also see if it ever crosses the asymptote. To see, some of them do, not many. To see if it crosses the asymptote, you need to make this equal to 3 to equal to the asymptote. And again, it doesn't often do it. So is equal to 3. You're going to get the 3 on the other side. You get 3x squared minus 6x minus 27 is equal to 0. You're going to solve for both sides. You're going to try to see if that has a solution. Now, I happen to have a quadratic equation calculator. And if it has a solution, it crosses. If it doesn't have a solution, it doesn't. So you can make these quite easily. Just let your Excel sheet do it, and I'm sure there's a quadratic equation. And it's saying that it does, which surprises me. It's saying it happens in 2 spots. Great. Let's just keep that in mind. It's saying it happens here and here. Interesting. I don't think that's true. So I think we actually have to, we actually can't do it like this because that's only works for polynomials. So we will have to ignore that result and then look at, here's how you do it. Sorry, my bad for jumping around. I'm just having my little moments. The whole thing has to be equal to 3. Which means you get 3x squared minus 6x. My bad. My apologies. And this whole thing has to go up to the other side to get rid of it. If you don't know what I did there, you need to practice more. Is equal to 3x squared. And you're going to discover when the 3x squareds cancel each other out. That's 12. And it's, and then it's minus 96. When the 3x squareds cancel each other out, you're going to discover they don't cross. So you're left with 18x, maybe. No, you're left with 6x is equal to 24 minus 96 plus 20. Let me make sure of my multiplication here. 96, 96 minus 24, 72 is equal to minus 72. So it's claiming that when x is minus, let's have a look. I don't believe this is true. When x is equal to 12, negative 12, it's going to cross through. Let's see if that's true. So we're going to put negative 12 in the calculator. 12 squared times 3 minus plus 72 minus 24. So I'm going to put that in the memory. And negative 12 squared is the same as positive 12 squared. Minus 4, that's plus 12, 24, 48. Minus 32. Then I'm going to take this and divide it by the memory and just take the reciprocal. No, that's not true. So I did a calculation error somewhere. Anyway, I'm going to get to that in a second. I'm going to spend more time. You should always set your thing to equal to your asymptote to see if it crosses. And this doesn't make sense that it would cross because I was negative here and then I was climbing up. And actually, you know what? It also doesn't make sense that, this is a positive value. Yeah, there we go. So it's on the hugging on the underside. Yeah, it doesn't make sense that it would cross, but I'll have to look later. You should always check. Now, going back, you should also check here, but let's just map what we have. Okay, let's map what we have. You can just take your top portion if you want. Man, I'm just going all over the place. And that means that I'm at right here. It's claiming it's hugging, going up and doing that. And right there I have a problem, right? So it's saying it's positive there. So how could it cross the x-axis and still be, oh, there, and so it does cross. There we go. That does figure it out. So somewhere, because the extreme value is just below the x-axis, it must cross. This must always hug. It's going to climb up here. It's crossing there. We should always label all your parts. So there's the y-intercept. You should label your x-intercepts. You should label your asymptotes, and you should label your horizontal asymptotes. Comes down and it'll always hug. And how I know this is from experience about the asymptotes. And there, just confirming that it was positive. Yep. So that's what my graph is going to look like. Right there, you're going to get good enough marks. But now that we're into the extreme, we want to find the maximum. There's no minimum, by the way, because this curve gently curves down forever, and this gently curves down forever. Might have a maximum. We're going to reveal it from the derivatives. So your next step is we need to find the derivative of that equation. So we're going to take this equation and we're going to practice our derivatives. And it's better to take this as a derivative. And you have to use your quotient rule, which means we're going to take this as my f of x, and this is my g of x. And a quotient rule says g of x squared at the bottom. You're going to discover that doesn't matter too much to the derivative. Okay? And it also means that f of x, which is the f prime of x, is equal to 6x minus 6. And g prime will be equal to 2x minus 4. And therefore the quotient rule says that I must take my this and multiply by my, and this is the painful part, is finding these. I'm going to end up with a cubic always. In this case, when a parabola quotient rule, you end up with a cubic. And it's going to be minus, and it's important to put your minus separate, times that. Okay. So there's your quotient rule. Don't worry, you're going to be able to pretty much ignore the denominator, which is intimidating, right? And you just got to practice your expansions. 6x cubed minus 24x squared minus 180, 192x. And it's very easy to make a mistake. Minus 6x squared plus 24x plus 192. Okay, group your common things. You only get 6x cubed minus 24x squared minus 6x squared is minus 30x squared. Minus 92x plus 24x is minus 168x, and then plus 192. There. Done. So the only thing you got to do correctly is put your cubes in the right spots. Messy, but good enough. So that replaces all of that. Then you got to do your other side. Good chance I can make mistakes here, because if I make any mistakes, it's here. So you get 6x cubed minus 12x squared minus 12x plus 24x. Ah, see? Look at that. Minus 3x squared minus 12x squared minus 24x minus 48x plus 96. Looking at the common, I get 6x cubed. Notice they're going to cancel out. I'm going to make sure I got this right on the x squared. I did. So I get minus 24x squared. And then I get minus 24x. I'm going to make sure I did that right. Minus 24x plus 48x minus 48x plus 24x. That is correct. And then plus 96. And that just means I want to get rid of that top part. Now the problem is this minus now affects them all. So I get a minus, a plus, and a minus. And now that can all be replaced with this. Now I look for cancellation opportunities. This will cancel with that most often. I'm left with minus 6x squared. So I'm going to rewrite that as minus 6x squared. I'm left there with 24x minus it's minus 144x. Minus 144x. And the last one I'm left with plus 96. That's what I'm left with. And I hope it was minus. Right? See, that's the sort of thing that plagues me. Let me just make a copy. Yeah, it's minus. Good. And then you want to take a minus out of it. You get 6x squared plus 144x minus 96. And now you want to use your... Now we're to find where max mins are. You set your derivative to equal to 0. Okay? Which means only that thing matters. The denominator doesn't matter. The denominator will matter if you want to find second derivative. And in this case, we're going to use their method, okay? Because second derivative is a whole new quotient equation. So we're just going to put that aside. So when you set the above to 0, you probably have to use the quadratic equation. Usually when the x-intercepts are clean, the max mins are not. So I'm going to set a 6. I'm going to set a 144. And I'm going to set a minus 96. And I get two possible answers. Okay. I'll just make sure I got it right. Yeah. I got two possible x values right here. And that means when that x is this, there's a max, could be a max, could be a min point. When that x is this, it's a min point. Now here's where you would go back to your chart, max or min point. Here's where you go back to your chart and see where those fall. And that'll help you determine the max mins as well. Okay. So let's see where those fall. And I'll just ignore my other stuff up here. So if x is 0.64, it falls in this range. And that tells me that's way up high. If x is minus 24, it falls in this range. And that also tells me, oh, so it's a dip down. So it crosses the y-axis and then dips back up. So it crosses the y-axis at minus 12. Has a minimum over there. That's interesting. And this will be my max because I know it's going up. Interesting. So just from my drawing, right, which I somehow have deleted, but look like this. What a beautiful drawing. This video is useless already. And my y-intercept, none of which I should have been deleting. I know that it's going to come down on the left side of my vertical asymptote, cross the y at minus 12, dip down to minus 24, and then rise up and hug the asymptote. So those are, once you plug x into your original equation, that's the derivative, the original equation, you will find a value there that you can mark as a max min. Now the other point, you remember, happened right here. It crosses the x-axis, comes up, and dips down, which means at 0.649, which is right beside the vertical, right beside the y-axis, you will have a max. So it'll actually bend down very soon after that. Let's see how many of these points we got right now. Obviously, you're going to plug it into the equation, label your points. There's you got a min point over here, you got a max point here, and you got all your stuff labeled. Let's see how close we were on that. This is a way of finding the max mins. Sure enough, there's a min point over there. It does indeed cross the... So I'm also going to, as soon as my computer stops glitching... Oh, life is fun. What a shame. What a shame. Jesus. Sorry about that. We'll be back in a second. I'm getting a new computer. This thing drives me nuts. Still didn't fix it. Sad. So when you set your 0 to equal to your derivative, it will draw vertical lines, and it will tell you where they cross. So you can see one there, and you can see we did indeed get the max and the min points. This also was a great indicator to tell us that we do indeed cross the horizontal asymptote. And look at that, there's that minus 12. So it did exist. A lot of information from doing these steps. Now, if you take the second derivative, it will tell you whether these are max or mins, but you could tell from correctly graphing whether these were max or mins. And x is equal to minus 4. X is equal to, what's the other one? 8. And those are the vertical asymptotes. So there, we have successfully drawn it. We've successfully mapped it. We have all the information we need. We could calculate right near the asymptotes. We don't really need to because there's no way it could cross the x-axis, and we know it's always going to try to approach the asymptotes. See? They always do. It was interesting to learn that it does indeed cross y, and it was interesting to learn that the min point is also exists over here. So not only does it cross y, it dips down and then hugs y again. Good stuff. Hope you learned something from that. This chapter, however, doesn't want you to learn that way. It wants you to just go through it all. I don't know if I have the energy to go through it all now. That was pure torture just because of technology. So I'll do what I can, okay? This might be a part 1, part 2. Again, always feel free to accelerate past it. But that mapping technique is, even though I bumbled through it, is the best thing you can learn because it's just impossible to map otherwise. So there's essentially asking us to find the derivative. Okay, you're going to discover derivatives of the cubics are always parabolas, and derivatives of parabolas are always straight lines. So when I take x out, actually when I take 3x out, I'm left with x plus 4. If I set that to 0, I discover clear points. 0, 1, I took the 0 and plugged it back in. I got 1. And then at minus 4, comma, minus 4 cubed, 16, 32, 64, negative 64, plus 16 times 6, which is 36, 96, plus 1. I might have gotten that wrong, but anyway, 97, 93, 33. These are the 2 points that exist where there's either a max or min. So what they would prefer you do is take a little point just to the left of this 0, like minus 1, and put it into the derivative to see if that derivative is negative or positive. If it's positive, you'll know it's sloping up to that point. So let's try that. Minus 1. We'll take minus 1 for here. Okay? So minus 1 becomes positive 1. So you get 3 and minus 12. So it's a negative. Just to the left of this is a negative. So it's coming up, which since this is a max or min, it must go down on the other side. So if I take 1 now, it's a positive. Interesting. So it's a negative. So it's going down if it's a negative, and going up if it's a max. So taking left side of that, of this point, tells me we've hit a min, because the right side derivative is positive and the left side's negative. Therefore, it's dipping down and coming back up. If you need to, you can do it again for this one, but so you would take minus 5 and put it in there. You get plus 75 minus 60. It's a positive. Just to the left of it is a positive, which proves it's coming up and then going down. So that's a max and that's a min. And that's how they want you to use this chapter to do it. So once you find your max or your min, you're not sure which, if you find the slope on either side of it, if the slope's positive and negative, it's a max. If the slope's negative and positive, it's a min. That's the only way that can exist. There, it's doing it right there again. So then B, this is a complicated one because it's really rephrased as x squared plus 4 to the half, which means I have to use the chain rule, and I get 1 over 2 square root of x squared plus 4 times 2x. So up here is 2x. The 2's cancel out. That's the derivative. I have to set it to 0, and I can see that only when x is 0, and it doesn't violate the rule down here, do we have it. So when I put x as 0 in here, up into the original, I get 2. So that means that this only has one max point or min point, and it's 0, 2. The only thing you have to make sure of is if that isn't the end point, because an end point isn't, it's the lowest point, so I guess it still counts. So we're going to take just to the left of 0 here, so minus 1. So we get 1 plus 5. So just to the left of this point, we get 5 plus 9, we get 3, positive. To the right of this point, we take 1 plus 4. Here's the tricky part. So negative 1 ended up being square root of 5, positive square root of 5. And on the right side, we're going to discover that it's also positive square root of 5. So what's going on with this? That's what's going on with it. So the right side should have actually been positive and the left side should have been negative, because if I look at this, so f of x is equal to, if I look at this, f prime of minus 1, it's a negative. So I should have actually gotten a negative. Oh, I had to plug it into the derivative, my bad. So I had to plug the negative 1 into the derivative, which is not that. I erased the derivative. It was 1 over this, no, it was x over the square root of x squared plus 4. And when I take negative 1, I get negative 1 up here, and that's a positive, so right away I know it's negative. And when I take positive 1, I know this whole thing's positive, which tells me, due to my failure mechanics, I got the wrong answer, and I should have just been more careful and not made that mistake. So obviously finding these derivatives gets harder and harder, because this is now the product rule combined with the chain rule and blah, 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 blah. Do I really have to explain to you how to take the product rule, set one of them to f of x, set one of them to g of x, find the derivative of both those, you got 2, you got 2x. Do the product rule, but you're going to discover when you take the derivative of this part, you're going to need actually to do the whole thing again. So if I'm going to take the derivative of this part, it's actually 2 times that times the 2, which is 4. So that's the derivative of that, times this plus the product rule, the derivative of this, 2x, times this. You're going to discover, setting all that equals to 0, that you have to expand it and do all sorts of stuff, and then you have to solve as a trinomial. Now, before you do all that, ask yourself some information about this thing. Notice the last part. So we essentially have 2x minus 1 times 2x minus 1 times x plus 3 and x minus 3. Okay? So it's a quadratic, it's a quartic. Comes down, crosses, goes up, comes down. And the spots it crosses here are 1/2, right? 1/2, so it does a dip at the x-axis here. So it really does this. Right here at 1/2, it dips back. Oh, then we got a plus 3 and a minus 3. So let's just do it properly. So if you draw it, it's crossing the axis at minus 3. It's crossing the axis at plus 3. And it's double dipping at 1/2. Now the problem is it must cross, coming down the first one. It's going to come up, the top of the W's there, and there. So that means right there and right there, I'm going to have 2 min points. Helps that I know that. So when you expand your thing and solve, you're going to discover that probably the cubics cancel out, and you're going to be left with something that's solvable. Do I really want to spend time solving that for you? No, I do not. So let's just see what this says. And the reason I'm not is because that was the last, we've done a million of those. You should be able to do it. So now I'm just going to set the derivative of x to equal to 0. Or rather, I'm going to set the 0 equal, there we go. Yeah, so yeah, the max point obviously where it dips on the graph, that's obvious enough. So it is going to be a quartic, and you're going to have to use your the information they give you, because you're going to know that this can be factored out of it, and you can have it be left with a quadratic that can be solved with the quadratic function. Now in university there is a cubic quadratic that you can use, but not in this grade. So I mean, fair enough, they kind of gave you a goofy thing to solve. The secret here is knowing this bit of information, that if you're stuck, you can factor that out of your last equation. To factor it out, you take, you can do synthetic, and you set half, and you do synthetic division into the cubic that this produces. And then you're going to be left with an x squared, and that you can punch into your quadratic. You could also discover that, as here it says minus 2 was one of the points, so minus 2 could also be, minus 2 could also be used in synthetic division. So it's all in deciphering it. Kind of a mean question actually to have in question 1. This is the quotient rule. Set your quotient. Let's see if we can do it super fast. Okay, 5 times x squared plus 1 minus 5x times 2x all over, and I'm going to ignore the bottom. So 5x squared plus 5 minus 10x squared. I get minus 5x squared minus 5. Take a negative out of it, negative 5. I get x squared minus 1. When x squared is equal to 1, I get a 0. So that means that x is equal to minus 1 and x is equal to 1. I could take a 0 to determine who's going up and who's going down, put it in here. 0, I get plus 5. So that means the slope between minus 1 and plus 1 is going up, which means I'm looking at something like that. I also discovered that there's no there's no asymptote here. There's no value of x I can put in. So my guess is we're looking at something that does this, crosses through 0, and has a little bump like that. So at -1, if I put this in, I get -5 over 2. And at +1, I get +1, I get 5 over 2. So you can see a weird little bumpy thing. Let's try it. 5x over x squared plus 1. Was it the square root of x squared plus 1? Or was it just x squared plus 1? Yeah, there you go. Right? How did I know go through 0, 0? Well, I could just go back and see that 0 was a possible when x is 0, y is 0. But also this is the only shape that this could really be and exist. So you can see that finding these things tells you a lot about what the possible shape is. Yeah, well, that's just take the derivative slope to the left and the right of your 0 points to figure out if it's decreasing or not. So kind of race through that. Oh, this is what they're applying to. They want you to state the intervals of increase. So for the sake of the fact that your teacher will be asking stuff like this, I will. So be careful. Yeah, it's increasing right there, but at the max, which here is at -1, you don't include it because at that point the slope is 0. So you'd say it's going from x smaller than -1 is a slope of increase. The other slope of increase occurs here, and you don't include the 2. So you would say n for x is bigger than 2 is an increase because it's going up. The slope is positive. The slope is positive. The only area of decrease is between -1 and 2, and you don't include them. So you go -1 smaller than x, smaller than 2 is a decrease. And that you don't include them because at those peaks the slope is 0. Therefore it's not decreasing or increasing. So that's how you do that one. Oh, that was probably terribly unclear. So here the slope is positive, right? And it never crosses x is equal to -2. So we'd say from, if you're doing this kind of notation, you would make it a round bracket because infinity is never included, comma, -2 round bracket because -2 is not included. So you'd say it like this. That is a range of increase. Where else is there a range of increase? Is there a slope positive anywhere else? No. So that's the only one that's increased between -infinity and -2. Where are the ranges of decrease? Well, there's 2. There's this one and there's this one. So this time, from -2 smaller than x, smaller than 2, is a decrease. It's always decreasing. And from 2 is smaller than x, smaller than positive infinity, is also a decrease. You just don't include the asymptotes and you don't include infinity. So this one in notation would be like this. Both rounded. Great. Be careful stuff like that. That does not have a derivative, even though it's an endpoint. And clearly they're stating the max min points quite obviously. So this one, the decrease is here and here. So it does not include this -1. So you'd say -infinity not included, comma, -1, or -infinity is smaller than x is smaller than not -1. And the other decrease, that's a decrease, the other decrease occurs from 1 is smaller than x is smaller than positive infinity. Written like this. That's the other decrease. The only increase is between this and that point. So it's from -1 all the way to +1 and not including. This one decreasing here, decreasing here. So you would say from -infinity, smaller than x, smaller than -1, and from 2 smaller than x smaller than 3 are the decreases. Those are the decreases. And the increases are here and here. So from minus 1 smaller than x smaller than 3 is the increase. Oh, sorry, smaller than 2. Right there to there is the increase. And then from 3 is smaller than x smaller than positive infinity is the other increase. Those are the intervals of increase and the intervals of decrease. Interesting. This is some of these you can do just by your knowledge, and you should always try to do it by your knowledge first. So let's look at our knowledge first. But Desmos before your graphing calculator. If you have a graphing calculator, you know how to use it, great. That's a cubic. It's starting in quadrant 1. It's going to cross maximum 3 times. But it also will only have a max and a min. And the first one's going to be a min, and the second one's going to be a max. So it would just be finding the derivative, setting it to 0. Right away I can see one of my points minus 2, comma 0. The other point is 0, comma 0. And from my knowledge I know that must be a min and that must be a max because quartics must follow. Sorry, did I bring it down from the top and the bottom? Sorry. Max, boom, like that, sorry. Quartics start in quadrant 3, my bad. The negatives start above. Like that and like that. My mistake. So I know that this will have to be a max and this will have to be a min. My mistake. All quartics start down in quadrant 3 and end in quadrant 1 when they are positive in front. Cubics. I keep saying quartics. Cubics. Same with 5s, and that's a positive 5, except that the 5 here can have as many as, if the cubic can have 2 max and mins, the 5 can have 4 max and mins. 1, 2, 3, 4. So if I take x to the 4 out of this, I'm left with, and minus x to the 4, I'm left with x minus, yeah, it can't be done for that one. If I put in 0, I'll see that it has a plus 100, so 0, comma 100, and that's some information. If I take the derivative, I get 5x to the 4 minus 20x to the 3. Now if I take x to the 3, 5x to the 3 out of both of that, which is what I meant to do, I get x minus 4. So I can see that it does a triple. So at a triple, it's kind of a slide, what I call a slide. Okay. So that means 0, the 0 point, will have this weird slide. And then at 4, we're going to have a max. And then it's going to go, ooh, technically it should have been a, so I'm going to make sure I did that, 5x4 minus 20x3. Take 5x3 out, I'm left with x minus 4. When x is positive 4, we're going to have a max or a min, which means I should have a min there. So that means that's a min. Great, that tells me a lot. Because 4 is the last one, it can only be a min. So that means I'm coming up, I'm wiggling, coming through, but I should have a max there, right? Interesting, I wonder what this looks like. Because it goes way up here to 100. And that should be a max. Oh, and that's where it's 0. So it doesn't, yeah, so at the y-intercept is where it does the wiggle. But it should have come down to create a min. X to the 5 minus 5x to the 4 plus 100. Is that it? 5x to the 4. So it didn't do a wiggle. So that's my bad, but it does only have 2 x-intercepts, so that's just a turnaround point. And yeah, I got the right point. So 4 had to be a min. So it didn't do a wiggle, and that was my mistake in interpreting that using the derivative. You can only determine a wiggle from that. From it only having 2 max and mins, I should have known automatically it has to turn around there, and 4 has to be a min. What about that? Well, that helps if you understand what it is on the proper fraction. That's the same as this. How did I do that? I converted this to an x over x denominator so that I could add them. I multiplied it by x over x, and I got that. So I get 1 plus x squared, or x squared plus 1, all over x. So it's clear there's an asymptote, right? And it's clear that this is always positive, right? So there's an asymptote right along the y-axis. And because this is always positive, this is one of those weird oblique, it's an oblique asymptote. So it's going to do this weird thing. And from this point on, it's just going to seem like a line. But when it approaches the x-axis, it's going to hug it. If you were to take a derivative, you'd have to take the quotient thing, but I believe you're going to find it has no max or mins from the shape of it. Even though I've drawn it incorrectly, it actually looks like this. And it has an oblique, God damn it. So I'm going to draw it. It looks like this. Looks like a normal line until it reaches there. And then on the other side, it's going to look like a normal line. It does the same thing. It's trying to reach that until it reaches there. Oop. Like that. It's a much better drawing. It's not going to have a max or a min. And I know this just from experience, but also because this square is one above that. So I know that to determine the horizontal line, I would divide this into there. I get x, 0, and then nothing. So I know that the line we're talking about is y is equal to x. And then this last one, the bottom can only be positive. You can never have an asymptote down here. So you're going to have a weird wiggle thing, which means it's probably going to have 2 maxims, 2 max and 2 mins. Oh, intervals of increase. Well, you can do that. So if I'm going to draw this last one, I'm going to see that right there it crosses the x-intercept at 1. So we're going to have this weird thing like this. Wherever the min point is, that's the interval of increase. That's the intervals of decrease. Verify your answers with, well, just take the derivative and set it to 0, and you'll discover that only the numerator matters. You're going to end up with something like this. Which means when x is 1, we have a max, and when x is minus 3, we have a min. And that means the interval of increase is between minus 3 and plus 1, and the intervals of decrease are between 1 and positive infinity and negative infinity and negative 3. This is just a quartic again. So we know it's going to start up in quadrant here, come down maximum 3 dips. You can see that they're all x, so if I can factor x squared out of it, I get a lot of information. Actually, I can factor no, just x squared. And I get 3x squared plus 4x minus 12. And if I look at that, I'm pretty sure I'm going to find a factorable thing, but this tells me there's a turnaround point at the 0. So if I look at minus 36 and I look at something that can add up to plus 4, I get, what is it, 9 and 4? No. 6 and 6? No. 3x squared plus 4x minus 12. 3, 4, and minus 12. Yeah, I get odd numbers, so, but I can see it crosses the y-intercept twice. So that's going to be the mins, and that's going to be the max, and that means the interval of increases here, and here, and here, and here. You just need to figure out the mins and the max. So you would set the derivative, which is 12x cubed plus 12x squared minus 24x to equal to 0. You would discover that you can factor 12x out of all of that. And you will get x squared plus x minus 2x minus 2. Is that right? Yeah. Is equal to 0. You'll discover when x is equal to 0, probably this one is a max point, which makes sense because 0, it's going to be 0, 0. And you'll also discover that x plus 2x minus 1 are the other min points. And so minus 1 will be here, and plus 2, and there you have your intervals right there. So they've given us the derivative. So clearly we can see there's 3 max or mins. And we know that if we were to multiply this out, it's a cubic, which means the derivative came from a quartic. Okay, so that's just logic. And this helps you to understand as well. Any x to the 4, the derivative is going to be x to the 3. Any x to the 5, the derivative is going to be x to the 2, etc., etc. Now they've given you the derivative, and it's x to the 3. If I multiply all that out, I get x to the 3 is the biggest term, which means it came from a quartic. It had to. Since quartics are shaped like that, or like that, depending on whether it's upward or downwards, I must determine these points. So I'm going to take, I know that one of them is minus 3, one of them is minus 2, one of them is plus 1. Now you might be tempted to say, great, I'm done, except that you don't know if this thing is facing upside down or not. So it might be actually something like, geez, how would I draw that upside? Actually, you know what? Yeah, maybe like that. So actually, I think that means it must be facing up. But anyway, what you do is you plug in a value just to the left of minus 3, so minus 4. And you get minus, minus, minus. And if you were to multiply them, that would become plus and minus, which means it's sloping down, which means that's the min point, that's a max point, that's a min point, which means the interval of decrease is from negative infinity to minus 3, and from minus 2 to plus 1. Those are the only 2 decreases. And the increases are from minus 3 to minus 2, and from 1 to positive infinity. Okay? And all you have to do is take the values just to the right or left to see if the slope's going up. So for instance, This is minus 2, this is minus 3. We can't. There's not much room. You could take minus 2.5, and this would be minus, and this would be minus, and this would be positive, which tells us the slope there is positive, because minus times positive is positive. Tells us it's sloping upwards. This is sloping upwards, and this is downwards, and this is sloping upwards, and this is has to follow the rules. Then I know this already. I'm not doing that because all they're doing is giving you backwards stuff. They're giving me an interval. It's got to satisfy these things. No. This might be Wild Goose Chase, number 7. But we'll try to figure it out. So we're missing A and B and C. We know that C is going to be the y-intercept. We know that from minus 3, it's just before minus 3, it's increasing. We know we've got a quartic decreasing to the point 1 comma minus 14. And then it goes back up. So we just don't know the wiggle point right here. Just to make sure, it will increase to the point minus 3, then decrease to the point there. Okay. Right. So, and this is a quartic. They've given us as a quartic, right? So it means it has to peak at minus 3, comma something, decrease to 1 comma minus 14, and increase, which means the derivative is going to be equal to 0 at that point. So let's take the derivative at both those points. So the derivative of this is 3x squared plus 2ax plus b. And I know two things. When x is 3, it's going to be equal to 0. Or when x is minus 3. And when x is 1, because they told me. So if I put 1 in here first, I get 3 plus 2a plus b is equal to 0, which means that b is equal to 3 minus 2a. That's just rearranging that. So that's one truth. Then when I put minus 3 into it, I know that 27 minus 6a plus b is equal to 0. And since I discovered up above an equation for b, I can replace wherever I see b with this, which means I get 30 minus 8a. Oh, sorry. That should, if this is rearranged, it's minus 3. So minus 3. So I get 24 minus 8a is equal to 0, which means 8a is equal to 24, which means a is equal to 3. And then I can go back up here, and I get b is equal to minus 9. So then if I go back here and plug those in, I can now find c. So let's try that, because now I know this whole equation, when x is 1, is also equal to minus 14. And I also know that I'm dealing with 1 cubed plus 3, 1 squared plus, or minus 9, plus c is equal to minus 14. So that's 1 plus 3. 1 plus 3 minus 9 plus c is equal to minus 14. So I get minus 5 plus c is equal to minus 14. And now I know that c is equal to minus 9 as well. And you'd want to go back and check. I might have screwed up the c, but you get the idea. Once you get a, b, you can plug it back into the original equation and use either of these points to figure out c. Sketch a graph. No. So they're giving you the derivative of essentially 4 different functions, and the confusing part is they call each of them f of x, right? So we're going to do one at a time. This derivative ended up being a line. And if I look at the equation of this line, I can tell that it is y. And what's the slope? It's going 4 down 2. So it's going negative a half, because it's going down 2. That's the rise for every run of 4. And I also know it goes through this. It's going to be this formula. Since I know it goes through 0, 2, well, I know that that's the, well, they give it right there. So I know that that's the b. So that's the derivative. So if I reverse derivative and know it came from x squared, I know it had to be this to get to that, right? And then plus 2x. And the only thing you won't be able to know is how much it's raised or whatever. You'd need a point for that. But since you know at 0 there's a min point here, you know the minimum of this thing is going to, because the derivative is 0 there, you know that when this thing is equal to 4 or has 4 in it, it's going to have the min point. So if I go from that logic, I get minus 16 plus 8 plus a mystery is going to be equal to my min point. So that's the problem, is I don't know my midpoint. I do know that the slope is positive here and negative to the right. So I know it's a max point, because these points to the left of my peak are positive and this is negative. So it's a max point. I know the max point occurs at 4 comma something. Oh, they give us right here. Assuming that f of 0 is equal to 2. Great. We now know that when x is 0, it's equal to 2. So right away we know our thing is 2. So now we know our equation is minus x squared plus 2x plus 2. And just to make sure, if I take minus out, I get x squared minus 2x minus 2. Does that work? Doesn't really work, does it? Let's put in 4 to make sure we got the right turning point. So we get 4, which is minus 16, plus 8, plus 2. We're going to discover the turning point now. Minus 4, minus 8, minus 6. So the turning point should be 4 comma minus 6. I believe that works. And if we now plug in 0, we'll get 2. So that's the y-intercept. So you essentially have something like this. You have a downward facing parabola, 4 minus 6, and it's going to cross. Oh, interesting though, it crossed the y-axis at positive 2. So that doesn't make sense. So go back to the drawing board. We have everything else correct. Okay. We know that when this derivative is equal to 0, well, first of all, we know this. Minus 2 minus a half x plus 2 is equal to the derivative, because that's what this is. Yeah, that works. We also know that reversing the derivative of this is the same as minus x squared plus 2x, and we just don't know the mystery number, is equal to our f of x. We know that it's sloping, has a positive slope before the max and the min. We know it's a parabola, and we know it has a negative slope after that. So we know that it's 4 comma something. We also know that f of 0 is equal to 2, which means that when x is 0, this whole thing is equal to 2, which means this must be 2. However, I don't know if that makes sense. F of x is equal to... Oh, that's the mistake I'm making here. That didn't come from that. To end up with that, you'd have to have a negative 1 over 4. That's the mistake I'm making. So, negative 1 over 4 x squared. How did I figure that out? Because when the 2 comes down, 2 goes into the 4, and I'm left with negative a half. So, this is the actual formula of the graph, and it has the vertex that I described. When x is 0, it's 2, and when x is 4, this becomes 4. This becomes plus 8. Oh, I got the wrong thing again. Oh, I just figured out the vertex incorrectly, that's all. So I get 4 plus 8, negative 4, plus 8, so plus 4, 6. So I get 4 comma 6. That makes more sense. So at 4 comma 6, it descends, goes through 0 comma 2. And that's the exact formula for that. You can figure that out because a line derivative will tell you all you need to know. That was a long way to really confuse the issue, which was actually quite simple. So because this is a derivative of a cubic, I know I'm dealing with a cubic. I also know it has a negative slope here till it hits a max or min. Sorry, a positive slope here till it hits its max or min. Then it has a negative slope to that point. So I know it's got a max here at minus 2 comma something, and I know it has a min here at 1 comma something. And I don't know the something because this only tells me when it happens on the x. It doesn't tell me where. The turning point, it has an inflection point right there at the x-axis, which you're not into yet. I also know, because of this, it's a positive. And I also know that the equation of this is minus 1. So x minus, so it'll be x. So the whole thing will be minus 1. So I'll get x squared minus 1. It's upward facing, so it's positive. I know it has an x minus 1. Oh, there we go. This is an easier one to use. X minus 1, x plus 1 is the formula of this derivative. When x is 0, it's minus 1. So far, so good. So I get x squared minus 1 is the formula so far. To come from a cubic, it would have to be a third x cubed minus, for the 2 to come down and disappear, it would have to be a minus x squared. There's no value for the other x, so there's nothing there, and it's just knowing that when it's 0, it goes through 2. Something like that. Let's see what that looks like. Cubed. Well, the only problem is it created my max at the wrong point. So I did something wrong there. Because it's got to, at minus 1, it's got to have a max point. Okay. So it's x squared minus 1 is definitely the thing. Which means it started off from an x cubed. So I'm just doing something wrong. So the derivative of that is x squared, and the derivative of that is minus. Oh, it's just an x there. There's no x squared in it. There it is. And still got it wrong. I got that part right. Oh, no, it's minus 1. So I also know the derivative of it. The derivative of it is equal to 0. At plus 1 and minus 1, so that's right. I know that it had to come from this. If this was originally an x, it's not a half x, just minus 1x. That half came when I thought it was cubed. There, got it finally. Jesus. Making this way more confusing than it had to be. This is had to be minus 1, and it only came from an x because it was just the derivative didn't have an x like that. Here's the derivative of it, by the way. There, see? A lot of confusion over nothing, sorry. You can see how overthinking. Now here's a line, so you should be able to figure it out fully on this. Just need to figure out the line formula. So it's rising 1 for every run of 2. This time it's plus a half. And it's plus a half x minus 1. That's the formula of this line. Since that's the derivative, it came from x squared. And it originally had just a minus x. And we just don't know what the mystery number is, except here. That's the mystery number. It is negative till it hits 2, and then it's positive. So it's downwards facing. Which is interesting. So how did it count for that if it's half x minus 1 is the correct formula? Oh, so that means no. If that's the derivative, and that's the correct formula, at 2, it's negative, and then at 2, it's downward. So we have to have a downward facing one. Wow, I'm just screwing this up over and over and over again. Let's just try this and see if that works. But no, it wouldn't have been. Let's go back. I don't like to cheat like that. So all to the left, the slope is negative, and all to the right, the slope is positive. Oh, it's not. It's, god damn it, it's upward facing. So this is correct. Plus x squared minus x plus 2. Oh, why did it? Oh, god damn. There we go. And I got something wrong. It's plus 2. And that line is not the correct derivative. So if that is plus half of x minus 1, the derivative came from x squared. Got that wrong again. Jesus Christ. So if this is the formula for the derivative, which it is, okay, that had to have come from an x squared. When the 2 came down, I was left with just a half. So that means it was a quarter in front of it. Then with the x came down, it was just minus 1, which just means it was minus x. Since at 0 over here, it's 2, there's a plus 2. So it's a quarter x squared minus x plus 2. Jesus Christ. And still got it wrong. Because this is not positive, it's minus. There it is, finally. Jesus. And yeah, we could have figured out what the vertex is once we had the equation down. You can see how many just little minor math things that it's just frustrating to do on tape. No. I mean, I could. It's the same thing. You're essentially converting this to the formula of where the vertex is. That's what that formula is. Okay, I'll do 11, 12, and then I'll stop. Okay. Sorry if this really was all over the place, but ultimately, if you correct your mistakes, it's okay. I'll probably redo this entire chapter. Find where f of x is equal to 0. Okay. The intervals, yeah. All the local extrema, okay. Using graph technology to verify. First step. Notice that there's no x cubed and no x squared. Okay. Notice we're dealing with a quartic that's positive. The derivative of it is this. So that's why solving it is easier. When you set it to 0, you're going to discover that 4x cubed is equal to 32. Therefore, x cubed is equal to 8 cubed, which means x is equal to 2. Problem is, we got one result that makes this thing accurate, right? And that's because of this shape right here. So go back and confirm it. There's only going to be one derivative, 32. So what does that mean? It means the whole thing is going to flatten out and do a weird flat thing and come back up at 2, comma, what? Let's put 2 in. 2 to the 4 is 4, 8, 16, minus 64 plus 4, so it's minus 44. You could also find out the x-intercepts, possibly, to see that you would punch in 1, 2, 3, 4. You're going to discover you need a fairly big number here to counter that. And it's probably going to have to be, that might be negative or positive. It's probably going to be like 4 and minus 4. And you could possibly find out where it crosses the y-axis, but that's the bottom. That's the minimum, just from what I know of the graph. The function's increasing from negative infinity to plus 2, but not including, decreasing. And it's increasing from 2 to positive infinity. And let's see. Okay, there's indeed only one spot where we have a minimum, and there it is. And that's just because a quartic can sometimes look like a parabola if you only have one max-min. I don't think it wanted me to find the... notice that the x-intercepts would require quite a bit of calculation. So, yep, yes, we did that. I'm just going to get rid of that. And there you go, that's your quartic. It only has one min. You can prove that by setting your 0 is equal to f prime of x. And you'll discover only one line shows up, because there's only one possible max min. Not sure why they gave us that. That's kind of a waste of time compared to the last ones. Oh, God. I don't quite understand this, the point of stuff like 12. I mean, I'm going to spend 30 seconds on it. Just mark their spots. Decreases from 0 to 3. So decreases to there. It's got a decrease. Elsewhere on the domain, the absolute maximum of G is 7. So this somewhere over here is 7. And the absolute minimum is -3. So somewhere over here is -3. So does that mean it does something like that? Why? Oh, local extrema. Oh, an absolute maximum. Okay, and the local extrema is 0, minus 0.4. Nah, what a waste of time. Sketch a graph. I don't. If your teacher asks you that, you get him to explain it. I'm not doing that. Yes, these are just like, I'm here to solve math, okay? The theoretical stuff, just ask your teacher. You can see that graphing is more important than any of this crap that they're asking.